Our dynamic universe. The key areas covered will be evidence for the expanding universe and estimations of the mass of a galaxy by the orbital speed of stars within it, and evidence for dark matter from observations of the mass of galaxies, and evidence for dark energy from the accelerating rate of expansion of the universe. What we will do today is discuss the evidence that shows the universe expanding at an accelerated rate, and describe how we can work out the mass of a galaxy. We will also discuss the evidence for dark matter, and describe how dark energy affects the acceleration of the expansion of the universe. The expansion of the universe. We can go to this website to have a little look at dark energy and the Hubble discoveries. I won't do that just now, I'll let you do that in your own time. What did the universe do at the start? The universe began with the Big Bang. All matter started the size of a grain of sand and then rapidly expanded. How would this expansion behave now? Everything in the universe that has mass has a gravitational pull associated with it. The bigger the mass, the greater the pull. As the universe is so full of mass, scientists thought that all the mass and subsequent gravity would start to slow the expansion of the universe down. So the universe is expanding. Is it speeding up or is it slowing down? Scientists believe that exploding stars were key to finding out about the expansion of the universe, and so decided to look for exploding stars, known as Type 1a supernovae. Just like car headlamps, you can tell how far away a star is by observing its brightness. Exploding stars always give off approximately the same brightness. The process of the explosion takes a few weeks, so they can be observed over this time period. So what happened when we found exploding stars? After finding some exploding stars, scientists discovered that the exploding stars were actually dimmer than they should have been. They had to be moving away. In fact, they were so far away that the only explanation would be that they were accelerating away and not slowing down. Was there any other evidence of this? Using calculations, scientists calculated the mass of the universe to be a negative value. This is impossible. They then realized that their calculations were based on the expansion of the universe slowing down. Redoing the calculations, assuming the expansion to be speeding up, showed that the universe must be expanding. How can we know what the mass of the universe is? The mass of objects in space can be estimated using their orbital speed. The masses measured seem to be bigger than the mass that can be accounted for by the number of stars present in our galaxy. Therefore, it is theorized that there is something else making up this mass, something we can't see, called dark matter. Did everybody agree with this? Doubters suggested that the stars weren't moving away and just appeared to be further due to space dust. The Hubble telescope, positioned out of the Earth's atmosphere, showed that this was not the case. So what exactly happened? Scientists now think this. When the universe was born in the Big Bang, it was expanding extremely fast. It was also much smaller and thus denser than it is today. Because the universe's mass was so close together, gravity began slowing the universe down. But in the background the entire time was this other mysterious repulsive force, the force scientists would become to attribute to dark energy. So what did dark energy do? As the universe continued to expand, though slowly, the galaxies containing the bulk of the universe's mass became further removed from one another. As the distance between mass became greater, the gravitational pull faded. As gravity weakened, the repulsive force took over and began forcing the universe to speed up. So what happens in the future? There are two possible outcomes of this. 1. A closed universe. The universe will slow its expansion and eventually begin to contract. And 2. An open universe. The universe will continue to expand forever. Einstein's greatest blunder. The increased expansion appears to verify Einstein's inclusion of the cosmological constant in his special theory of relativity. He described this as his greatest blunder. He only added it because he couldn't agree that the universe would eventually collapse, which was a popular theory at that time. Unfortunately, he died before the evidence to support his theory was uncovered. Here's an experiment we could do. An experiment that can be done to simulate the expanding universe uses a balloon, a pen, and a tape measure. First, we would mark 6 dots on a balloon, and blow the balloon halfway up, and then circle one of the dots. This would be the Milky Way. We would then number the other dots. These would be other galaxies. Then we would measure the distance from the Milky Way to each galaxy and record it in a table. Then we'd blow up the balloon fully and remeasure all of these distances. After this, we would calculate the average velocity of each galaxy using the difference between the two distances measured and the time it took to blow up the balloon using a speed-distance-time equation. What we would see from this experiment is that the further the galaxies were initially from the Milky Way, the distance they travelled when the balloon was fully inflated was larger. So, the further away the galaxy, the higher the average velocity. Some limitations of this are that the surface of the balloon was only two-dimensional. In real life, the universe is three-dimensional. A better way of showing this in an experiment would be baking a cake with perhaps some raisins or some chocolate chips in it. When the cake rises, these chocolate chips would expand in 3 dimensions. They would move apart from one another. However, this would be much more difficult to measure in a classroom as the chocolate chips would be inside a cake. So the universe is expanding. The universe has been expanding since the Big Bang. The objects within the universe, so the galaxies, are not expanding, but the space in between them is. The expansion of the universe is actually accelerating. All galaxies are moving away from each other, and so the gravitational pull is decreasing. Dark energy is accelerating the expansion of the universe. So what evidence is there to support this? We can estimate how far away something is by its brightness. Exploding stars in our galaxies are moving further away at an accelerated rate. Light from some distant galaxies was observed to display a redshift, showing they were moving away at speed. Measurements of the mass of galaxies support the theory of dark matter or dark energy. What is the mass of our galaxy, the Milky Way? One method that astronomers have used to calculate the mass of the Milky Way galaxy is to use Kepler's third law that relates orbit radius and period with central mass. We figure out the radius of our orbit relative to the center of the galaxy and the period, which is the time it takes to complete one orbit. We put those numbers into Kepler's third law, we can estimate the mass of our orbit. Doing the maths, we come up with a number that's just shy of 100 billion solar masses, with one solar mass being equal to the mass of our Sun. The overall mass estimates of the Milky Way are on the order of 750 billion to 1 trillion solar masses. We do not need to actually calculate the masses of any of these galaxies, we just need to know how it's done. How is the mass of the universe related to its expansion? It was thought that the gravitational pull of all the mass in the universe would slow the expansion. However, as the universe expands, the force of gravity is decreasing. Additionally, there must be another invisible force pulling the universe. This is known as dark energy. So what is dark energy? Measurements of the mass of our galaxy and others led to the conclusion that there is a significant mass which cannot be detected, dark matter. Measurements of the expansion rate of the universe led to the conclusion that it is increasing, suggesting that there is something that overcomes the force of gravity, dark energy. Here is an open-ended question to try. A student explains the expansion of the universe using an expanded balloon model. The student draws galaxies on a balloon and then inflates it. Using your knowledge of physics, comment on the suitability of this model. This is worth 3 marks. Here is a possible answer. Yes, the universe is getting even bigger. Astronomers believe that the universe is expanding, that all points in the universe are getting further apart all the time, just like a balloon blowing up. By drawing the galaxies on the balloon, you can observe that it is not the galaxies themselves that are expanding, as you blow the balloon up over time, but the space in between them, just like in the universe over time. It can also be used to work out the speed of each galaxy by recording the distances between the galaxies and the time taken to increase these distances when blown. The more you blow up the balloon, the faster the speed, i.e. acceleration. However, this model shows how the expansion works, but it's only a 2D model, whereas the universe is 3D.